vector quantity cannot be joules, this is our energy or mass or kilogram, it is Newton for force. So we have S equal half AT squared, rest U equal 0, so this is proportional to T squared. So the white ball as it has V and the red ball as it was stationary with 0 speed, after collision white become stationary but the red has V. This means that momentum totally transferred from white to red ball, especially as both of them have same mass, and also this means that kinetic energy totally transferred, because by the way kinetic energy is half mv squared and can be written as momentum squared divided by 2m. So if m is the same, momentum is the same, kinetic energy is the same. To calculate work, the force that is used in calculation should be in the direction of the distance cut, or vice versa. The distance cut should be in direction of the force. So we can say that we have a horizontal component for the force, and we can multiply by x, okay? But as this angle is theta, horizontal component will be f cosine theta, and when you multiply by x, it will be x f cosine theta, which is not exist here in choice. So we should think about the distance in the direction of the force, which is the length of this hypotenuse, and this length can be given simply by square root of x squared plus y squared. But again, when we multiply by f, there is no choice like that. So we can think about the hypotenuse length in terms of trigonometry. We have this angle theta, so sine theta, for example, equals y over the hypotenuse, the distance s that we want, okay? Or cosine theta equal to x over s, as s from this equation is equal to y over sine theta, and from this equation over cosine theta, x over cosine theta, it is clear that answer will be B. Okay. Someone may say how it can be if cosine theta times x, and in same time if x over cosine theta. The answer is, if we say x if cosine theta, we will then calculate work done by the horizontal component of f, okay? But we want here the work done by f, so it is not either x f cosine theta or fx over cosine theta, it is only fx over cosine theta, because this formula is only for work done by the horizontal component. We can name it as fh, f horizontal. Okay, so although we always say that multiply a force in some direction with distance cut in this direction, you should differentiate between which force you used. Either is a component of the force or the whole force. Okay, I suppose that this doesn't happen for the distance, because whatever the way you calculate the distance, it is obvious and uh, no um, misunderstand of it. Simply two components is squared under square roots. Constant deceleration needs a straight line with negative slope. So Newton's third law pair of forces needs four criteria. First, they must be equal in magnitude. Second, opposite in direction. Third, same type of force between two different objects. So the pair for force of cord on parachute, okay, should be force of parachute on cord. A act with the force on B, B act on with same magnitude opposite direction from B on A. We cannot involve a third object C, so you cannot say weight of person. Okay. Okay. So we know that E equals F over A x over delta x for same E in the second case, F over A2 times the new length over the new extension. This equals F over A2, and as the new length is twice, okay, let us just name it as L2, just not to mix things up. So we have here 2 L2, okay, over delta x. If we equate this magnitude to this magnitude, because both of them equal E, we can simply eliminate from the two sides of this equation f and delta x. Hence we have the left is x over a equals 2 over a2. So what we need here is an answer that has a ratio between length and the cross section, the new length and the new cross section. This ratio to be x over 2a. Okay, this is proven from what we got here. So we need any length over a cross section that matches this value. Let us see x over half a. This means something like that, which means 2 goes up, so cannot be the answer. X over 2a, this is exactly the same ratio. Okay, so to find the change, we can simply say that elastic energy after, which is half 350, okay, minus half times almost, and after that we can get the half as a times 10 to minus 3 as a common factor. So we have here, okay, this on calculator is so we need something that gives 2,400 times half times 10 to minus 3, which is not this, neither this. This is 400 times 6, 2,400 times 10 to minus 3 over 2. So the answer is C. Okay. As forces on 3 kilo are in equilibrium, this means that force on spring equal to the weight attached to the spring. Okay. So if spring equals 3g plus 2g, which is 5g. As we removed the 2 kilogram and the 3 kilogram will move up, we have this force divided by 3, okay, but we have basically the resultant force on the 3 kilogram that when we divide by 3 we get the acceleration, the upward acceleration. Let me write it as F resultant on the 3 kilogram divided by the mass gives the wanted acceleration. F resultant is Fs minus the 2g, which is the weight that had been removed, over 3. This gives sorry, not the weight that has been removed, I mean the weight that remained. The force is here downward, so it is, let me draw it. After removing the 2 kilogram, the resultant force Fr equals the Fs that try to restore the spring minus the weight, which is the weight remained of the 3g. Okay. This is divided by the mass of this object, so we can find the acceleration. Fs as we calculated 5g minus 3g, so it is 2g over 3. Okay. Okay. So simply we can make a scale of 5,000, for example, for the big square, and we have weight 15,000, which means 3 big boxes down. Okay. This is the weight, and we have forward of 7,500, which means one big box plus a half. Okay, this is F, and we want the normal contact force. It accelerates in horizontal direction, so in vertical direction the forces should be equal to have zero resultant force, or equilibrium in vertical direction. I'll extend the arrow up. Okay, this is the normal force. Again, the useful output here is the work done on the load, which is and as we have efficiency as total useful output power, which is output energy over time over total input energy, or power, which is energy over time again. So this is 0.38 E out this T is a denominator here, so we can rearrange in this way. T equals over, I can write this as 5,700. Okay. So, as Newton's second states that force times time equal to change in momentum, and we have force and time the same. Okay. Question states that these forces have same magnitude and act for same time, so force and time are the same, so delta B is the same. Okay, but they act in opposite direction. Okay, so as VA decreases, VB will increase. So this means that total change in momentum is equal to 0, thus B is conserved. Whenever any quantity that delta this quantity equal to 0, this means that this quantity is conserved. If, for example, delta V is 0, change in speed is 0, this means speed is constant. Even if the object is stationary, this means that its speed remains 0, equal 0. Okay, or it can a constant speed of 3 meters per second, for example. So initial as final 3 meters per second, and delta V is 0, so acceleration is 0. Any delta for any quantity, when it equals 0, means that the quantity is constant. Okay, so we have same delta B for both spheres, and the forces, okay, in opposite direction, so delta B is in opposite direction, okay, and one of them was stationary before the collision, so it becomes moving after the collision, and total delta B is 0, thus be conserved. Okay, we have half times 17 times VA squared, okay, equal to 3.8. This is the kinetic energy of stone A. So we can find the A as sorry, this is 18. We can now apply conservation law of momentum. This is for A, and for B it is 0 because it was stationary before collision. And here is the situation after. Simple rearrangement, we can get BA as this value is less than the 5.5 value, okay? And when I said less than, confidentially, I say that because the difference between the two values is 0.36, which is 0.4 or 40%. So as this value less by 40% than this, there will be no slide, because the minimum is 5.5, so no slide. To have the resultant moment equal to 0. This question is simple if you just focus on the perpendicular distances. Perpendicular distances from the pivot, which the question thankfully stated to be B. Okay, so makes you not hesitated about which point to take the moment about. Okay, we need here to find the moment for two forces, the weight. Okay, from pivot, this is the perpendicular distance, which is and the force F here is its perpendicular distance. How to get this distance? We can simply use the angle 55. We can use the tan because we don't have this lens. Sine or cosine needs hypotenuse. So only tan can give us this lens. Okay. Okay. So tan 55 equals 0.16 over our distance, our wanted distance. So we can substitute here as okay. Can make it for 3 significant fig. Condition for Stokes law to be small, regular, or uniform object and move with low speed, and for the flow to be laminar. So this for the object and this for the flow. Okay, we first write the formula for drag. We need Vt as the vertical motion here is under acceleration, okay, that is 0, and for this we have a constant velocity. We can simply divide the distance cut by the time. If you want to confirm your choice for just dividing distance by time, here is the equation of motion. This cannot be used because we don't know initial or final, or how we get from this initial to this final. So this equation cannot be dealt with if we used this equation. We also cannot use it because again we don't have acceleration. This final situation is at constant velocity, and same as v equal u plus at. Again we can use it, but if we used s equal ut plus half at squared, even this term is equal to 0, we still have s equal ut. So we have here 6 pi all of these values are given in the question, and with respect to Vt, it will be 0.056 meter over 1.3. I choose to convert here because all of these units in SI. Okay. So we need the viscous drag, and we know that both upthrust and viscous drag is equal to W, the weight. Okay, this condition because of the terminal velocity. So D equals to W minus U. W is 2.4 times, and U is rho of the liquid or mixture times G times the volume displaced as the ball is totally immersed. So it is the volume of the whole ball. And I converted the millimeter. Okay, you can do this in your calculator, and the answer will be, sorry, 90. To straighten string. We can increase the length x, and as absolute uncertainty is the same, the percent uncertainty, which is equal to the absolute uncertainty over the value of x, will be decreases. Okay, percent uncertainty will decrease. Okay. And we also view perpendicular to scale to avoid parallax error. Okay. It's a simple calculation. Just you should remember that giga is 10 to 9. This value approaches 5, so it is the 9. Kinetic energy here acquired by the box will equal to the change in gravitational potential energy. Okay, so we have we can eliminate m from both sides. We have range for V. Substitute and after that we can use the equation of motion. Okay, which equation of motion? V squared equal u squared plus 2as. Certainly u squared equals to 0, so it is just 2as. Okay. Okay.